Have you ever looked at the news and felt, well, a little confused? We see these headlines about record floods in one part of the world and then crippling droughts somewhere else. It feels like our planet is sending some seriously mixed signals. So today, we're going to learn how to read those signals and figure out what's really going on.
Okay, let's just get right into it because this is the central puzzle, isn't it? More floods and more droughts. How on earth is that even possible? It sounds like a complete paradox. Well, to solve this, we're going to have to put on our detective hats and learn how to find the clues hidden in plain sight.
First things first, every good investigation starts with knowing the layout of let's call it the crime scene. And for us, that means getting a handle on Earth's freshwater system. Where is all this water and how does it get around? So think of Earth's freshwater as being in three main places. You've got water up in the air, that's your clouds and water vapor. You've got water on the ground, in rivers, lakes, and all that snowpack. And then there's a ton of it hidden below the ground in what we call groundwater and aquifers. The key thing to remember is that it's all connected and it's always moving between these zones. All right, now for what I think is the most important skill for any climate detective, cracking the code. We've got to learn how to separate the day-to-day chatter of weather from the real long-term story that the climate is trying to tell us.
I love this quote because it just nails the concept perfectly. Weather is that immediate decision, should I grab an umbrella today? But the climate, that's the reason you own an umbrella, a winter coat, and a pair of shorts in the first place. It's the whole collection, the long-term pattern.
To put it another way, weather is what's happening right now, today. Climate is the story that gets told when you look at decades and decades of data. One is a snapshot, the other is the whole photo album. And to find the real clues, we need to look at that whole album.
So when you look at data from one year to the next, it's going to be all over the place. A really wet year, then a really dry one. That's totally normal. It's called short-term variability. Scientists have a great name for it, weather noise. It's kind of like the static you hear on a radio in between stations. But if we can just tune out that static, we can start to hear the music underneath. That's the long-term trend, what scientists call the climate signal. And that is the clue we've been looking for. It's the real story hidden beneath all that year-to-year noise.
All right, detective, you've got the basics down. So now it's time to put these new skills to the test. Let's look at some actual data from a community and see if we can spot that climate signal for ourselves. Okay, so take a look at this chart. This shows the rainfall for one place over many years. See how that line jumps up and down like a pogo stick? One year it's way up, the next it's way down. That right there is a perfect picture of that weather noise. It looks completely random. But now watch this. When we draw a line that averages out all those wild swings, that blue line, that's our signal. It cuts right through all that noise and shows us the underlying pattern. And in this particular case, you can see that over the long haul, the average precipitation has actually been pretty consistent. Okay, so we've figured out how to find the signal in the noise. Now let's zoom out and apply this skill to our original mystery. We're going to look at evidence from very different communities across the country to see what's going on. So we're going to compare two places that are living completely opposite realities. One is a community that's been struggling with severe drought, and the other is a place that's seen some really extreme floods. Let's see what happens when we put their data side by side. And here it is. This is the big aha moment. On the left, you have a county in California that's been hit hard by drought. On the right, a county in Colorado with a completely different water situation. Now, their water stories are polar opposites, but just look at their temperature trend lines. Just focus on those. Do you see it? They're telling the exact same story.
It's absolutely unmistakable. I mean, despite all the weather noise, despite being in different parts of the country with different water problems, the long-term climate signal for temperature is pointing in the exact same direction for both of them. Up. And we can actually measure this. It's not just a feeling. In Tulare County, for instance, the temperature has been climbing by about 0.2 degrees Fahrenheit every single decade for more than a century. It might not sound like a lot, but that is a slow, steady, and relentless drumbeat of a climate signal. So, we've looked at the evidence, we've learned how to separate the noise from the signal, and now it's time for the verdict. What does all this data actually tell us? Okay, here's what we figured out. First, those wild year-to-year swings in weather, that's just noise, and it's normal. Second, you can only see the real trend, the climate signal, by looking at data over a long time. And finally, while some places are getting wetter and others are getting drier, the one constant signal we found everywhere we looked was this: temperatures are rising. That's the common thread that ties this whole story together.
So we've solved the what's happening part of the mystery. A warmer planet basically supercharges that whole water system. Warmer air can hold more moisture, leading to more intense, flood-causing downpours in some places. But at the same time, that extra heat sucks more moisture out of the ground, making droughts worse somewhere else. So that explains the paradox. But of course, that leads us to the next, even bigger question: why is this happening in the first place? And that, well, that's an investigation for another time.